Welcome to Science for Sleep, where wonder and calm meet. Each night we drift through galaxies, oceans, and mysteries of the natural world, not to startle, but to soothe. In the quiet darkness between the stars, there is a distance so vast and so patient that even light must take its time to cross it. And it is toward this distant glow, the Alpha Centauri system, that our journey gently begins. There is a quiet truth about the universe that only reveals itself when you sit with the idea long enough for its scale to settle in your mind. It is the truth of distance, not the kind of distance measured in footsteps or kilometers, but a distance so vast that the human sense of scale dissolves into something softer, something more contemplative. When you think of Alpha Centauri, the nearest star system to our own, it is easy to imagine it as just another point of light in the night sky. But that small point of light carries a depth of space behind it that stretches farther than thought can comfortably reach. The space between stars is not an empty gap, but a vast, silent ocean, one that holds time in a way that feels both immense and delicate. To understand how long it would take to reach Alpha Centauri, you must first allow yourself to drift across that ocean in your imagination, letting each fact unfold slowly, gently, like ripples spreading across still water. As you picture the night sky, that familiar faint glow scattered across darkness, you might not realize you are looking not at the surface of something, but into its interior. The Earth and the Sun are small, quiet residents inside a galaxy filled with hundreds of billions of stars, each one separated by distances that are difficult to fathom. Our nearest stellar neighbor, the Alpha Centauri system, lies just a little over 4 light-years away. 4 years for light, traveling at the fastest possible speed to cross the emptiness between our sun and that distant trio of stars. Light moves so quickly that in a single second, it circles Earth 7 times. And yet, even at that unimaginable speed, it needs more than 4 years to bridge the gap. Imagine that for a moment. A beam of perfect, uninterrupted light stretching through space for over 1,000 days before reaching its destination. This is the scale you are drifting into. Alpha Centauri is not a single star, but a small gravitational family. 2 stars, Alpha Centauri A and Alpha Centauri B, orbit each other in a slow, celestial dance, their warm golden light blending softly across the system. Farther out, moving on a lonely, wider orbit, is Proxima Centauri, a small red dwarf that glows with a quieter, cooler light. It is Proxima Centauri that lies closest to us, and so it is often the target of humanity's first imagined interstellar voyages. Even then, to say closest is to use the word gently, for it remains at a distance that challenges imagination. If the Sun were a sphere the size of a grapefruit, Proxima Centauri would be another grapefruit sitting hundreds of kilometers away, with nothing but vast, silent space between them. To understand how far this truly is, try to picture the familiar distances of your own solar system. The Earth is only 8 light minutes from the Sun. Even Pluto, drifting quietly on its cold, distant orbit, is still not even a full light day away. But Proxima Centauri is more than 15 million times farther than Pluto. Every spacecraft humanity has ever built, every technological marvel we have sent outward into the cosmos, has traveled only a tiny fraction of that immense gulf. And yet, in the quiet of thought, you are free to drift there without resistance, carried by the simple act of understanding. The measure of a light year is not just an abstract number. It is a reflection of the universe's vastness. Light travels at nearly 300,000 kilometers per second, and in 1 year, it covers nearly 10 trillion kilometers. A journey of 4 light years is therefore a journey across nearly 40 trillion kilometers. These distances are hard to hold in the mind all at once, so let them unfold gently. Imagine a single kilometer, then imagine 1,000, then 1,000,000, then 1,000,000,000, then 1,000,000,000,000. Now imagine that number multiplied several dozen times. And finally, imagine yourself floating somewhere within that expanse, a small observer in a space so wide that even numbers begin to feel quiet. When you think about traveling such a distance, it becomes clear why reaching Alpha Centauri is not something we can do with the technology of today. The fastest spacecraft we have ever launched, like the Parker Solar Probe, travels at speeds that would carry it around Earth in minutes. And yet, even at those extraordinary speeds, the journey to Alpha Centauri would take thousands of years. Thousands of years of steady motion through darkness, long after the memory of the launch had faded from the minds of those who witnessed it. Thousands of years of drifting across a space so quiet that even starlight takes years to cross it. The idea is both humbling and beautiful, a reminder of how small we are and how vast the place we inhabit truly is. But the question of how long it would take to reach Alpha Centauri is not only about speed, it is about understanding space itself. The space between stars is not empty. It is filled with thin traces of gas, with dust, with magnetic fields stretching like invisible threads through the darkness. It is a quiet place, but not a void. Particles float there, drifting slowly, waiting for the gentle touch of gravity to gather them into clouds that may one day become new stars. Radiation from distant suns travels through it, softened by distance until it becomes a faint whisper of energy. Cosmic rays flash through it in long, silent paths. Even in emptiness, the universe is full. As you drift deeper into this thought, it becomes easier to imagine the journey not as a straight line, but as a slow crossing of many different kinds of space. Near the sun, the journey begins in a region shaped by the solar wind, a gentle outward flow of charged particles that creates a protective bubble around our solar system. At its boundary, this bubble meets the true interstellar medium, the quiet, cold environment that fills the galaxy. Beyond that point, the spacecraft would move into a realm shaped not by our sun, but by the collective presence of every star in the Milky Way. Gravity would tug gently from all directions. Starlight would dim. The temperature would fall toward the cosmic background. And slowly, steadily, the craft would drift toward a distant speck of light that grows almost imperceptibly brighter with each passing century. Humanity has long wondered what it would take to bridge that distance more quickly. And so we imagine engines that burn hotter, sails that ride beams of light, fusion drives that glow like miniature suns, and spacecraft that move not by pushing against space, but by bending it. These ideas belong to future chapters of this journey. But even now, thinking of them allows you to see the journey not as an impossibility, but as a slow, unfolding conversation between aspiration and the enormity of space. The universe welcomes curiosity. It allows thought to travel freely, long before machines can follow. When astronomers first measured the distance to Alpha Centauri, they did so by watching the tiny shift in its position against the background of more distant stars. Using Earth's orbit as a vast cosmic ruler, that small shift, less than a pinprick of motion, revealed the system's true distance. That is how we learned that even the nearest star beyond our sun lies impossibly far away. And yet knowing this distance does not diminish the sense of connection. If anything, it deepens it. The stars you see in the sky are lights from other suns, and Alpha Centauri is one of them, a neighbor whose glow has traveled years through space to reach your eyes. As you drift in thought toward that distant system, you might imagine its stars as they truly are. Alpha Centauri. A. A warm yellow star very much like our Sun, steady and bright. Alpha Centauri B, slightly smaller and more orange, glowing with a calmer warmth. And Proxima Centauri, the small red dwarf, cool and dim but full of gentle persistence, shining quietly in its long, slow rhythm. Around Proxima Centauri orbits a planet, Proxima B, a world not very different from Earth in size, though conditions there remain uncertain. Its presence reminds you that even in the vast quiet between stars, there may be other worlds where sunlight warms a landscape, where time leaves patterns upon stone, where silence holds its own kind of story. The journey to Alpha Centauri, then, is not simply a matter of distance or speed or engineering. It is a reminder of the scale of the galaxy we call home. Our Sun is just one star among hundreds of billions, drifting in a spiral arm of the Milky Way, circling the galactic center on a journey that takes more than 200 million years to complete. You and everything you know move with it, carried through space by a motion so vast and so steady that it becomes a kind of cosmic heartbeat. And somewhere out there, among the countless lights scattered across the darkness, lies a small cluster of stars that appear close only because they are less far away than all the others. If you allow the idea to settle softly, you begin to see the question differently. How long would it take to reach Alpha Centauri? Is not just a question about travel time. It is a question about how you understand your place in the galaxy. It is an invitation to step back gently from the immediacy of everyday scale and drift into a larger frame of reference, one where distances are measured in years of light, and journeys are counted not in hours, but in centuries. It is an acknowledgement of both the limits of our current technology and the vast potential of what may one day be possible. Even now, light continues to travel between the Sun and Alpha Centauri. It moves steadily, patiently, with no need for fuel or engines, crossing the gulf in silence. That light carries information: the color of the star, its temperature, its subtle shifts caused by orbiting planets. It is a constant reminder that connection across distance is always possible, that even in the vast quiet of space, nothing is truly isolated. The space between stars is immense, but within that immensity, there is a subtle thread of continuity that binds them together. As you reach the end of this first chapter of thought, you are not yet at Alpha Centauri. You are simply aware of the distance that lies between here and there. A distance measured in light years, a distance crossed effortlessly by thought, patiently by light, and perhaps one day, slowly and steadily, by the machines humanity builds. For now, it is enough to understand the scale, to hold it gently in your mind, to feel the quiet wonder of living in a universe where such distances exist. The journey continues, not with engines or motion, but with understanding, a slow, calm unfolding of the space between stars. The first dreams of interstellar travel. There is a quiet shift that happens when you begin to imagine not just the distance to Alpha Centauri, but the possibility of crossing it. The question becomes not only, how far is it, but how have humans imagined reaching it? Long before any spacecraft left Earth, long before telescopes revealed the shapes of distant nebulae, the idea of traveling to another star existed as a kind of gentle dream, a whisper of curiosity carried through centuries of thought. As you drift into this chapter of the story, you move back in time, into eras when the stars were maps for sailors, myths for storytellers, and mysteries for early scientists trying to understand the universe from the limited vantage point of a small world. Even in ancient times, people looked at the night sky and wondered what lay beyond. The stars were fixed points then, shining with steady light, seemingly eternal. No one knew what they were made of, how far away they were, or whether they were worlds of their own. Yet the sense of wonder was already there. A quiet awareness that the universe extended far beyond the boundaries of Earth. That feeling has not changed. You carry it even now, softly, in the back of your mind. Whenever you look up at the night sky and feel the gentle pull of something distant and mysterious. But it was only in more recent centuries, after the birth of physics and astronomy, that humanity began to imagine interstellar travel as a possible future rather than a mythic idea. Once scientists understood that the stars were suns like our own, that their light took years to reach us, and that their distances were measured in trillions of kilometers, the dream of reaching them took on a more grounded form. It became part of the quiet, steady march of scientific curiosity. A question not of fantasy, but of possibility. In the 19th century, before rockets existed, before even the concept of spaceflight was fully formed, a few thinkers began to ask whether humans could ever leave Earth. They imagined space as a cold, airless void, a place where ordinary travel was impossible. Yet the idea persisted, gentle but unbroken. The first voices to dream of reaching the stars were not engineers or astronauts, but writers. Jules Verne, H.G. Wells, and others who allowed their imaginations to drift beyond what their world considered realistic. They planted seeds of thought, seeds that would take decades to grow into scientific ambition. When the 20th century arrived, it brought with it the first scientific theories of rocketry. Quiet equations written by individuals working alone, often without recognition. Konstantin Tsiolkovsky, a schoolteacher in Russia, imagined rockets powered by the steady push of expanding gas climbing through the air and into the vacuum beyond. He wrote his ideas in long, thoughtful paragraphs, blending physics with a sense of wonder. In one of his notes, he spoke of humanity not remaining on Earth forever, but eventually journeying into space. His words carried a soft clarity, not a command, but a vision of what could be, given time, patience, and understanding. As decades passed, the dream grew stronger. It moved from imagination to engineering, from isolated ideas to laboratories and test fields. Robert Goddard in the United States, Hermann Oberth in Germany, and other pioneers began building actual rocket engines. Their early machines were small, brief bursts of flame and metal. They lasted only seconds, rising through the air with a sputtering glow. And yet, those brief seconds marked the beginning of something profound, the first real attempts to break the boundary between Earth and the vastness beyond. When humanity finally entered space in the mid-20th century, when the first satellites hummed softly above the planet and the first humans drifted in orbit, the dream of reaching other stars ignited again. But this time, it had a new shape. It was no longer a question of imagination alone. It had become a question of engineering, physics, and the limits of speed itself. Scientists began to calculate how long it would take to cross the distance to Alpha Centauri, using the technology available at the time. The answers came back not in years, but in millennia. Thousands upon thousands of years. Imagine hearing that for the first time, the realization that even the fastest spacecraft humanity could build would take longer than recorded human history to reach the nearest star. It was a sobering truth, one that settled quietly across the scientific community. The universe was vast, and human technology was small. But even then, the dream did not fade. It softened, changed shape, and began to take a new form, one rooted not in near-term possibility, but in long-term aspiration. As you drift through these early decades of thought, you can sense the mood of the time, a mixture of excitement and humility. The stars were finally becoming objects of scientific study rather than distant mysteries. Telescopes revealed planets around them, atmospheres, magnetic fields, and gentle swirls of dust. Space probes sent back images of worlds within our own solar system, each one different, each one carrying its own quiet beauty. These discoveries did not push the dream of interstellar travel away. They brought it closer, by reminding humanity how rich the universe truly is. By the time the Voyager spacecraft were launched in 1977, carrying their golden records into the depths of space, the dream had evolved into something more philosophical. The Voyagers were not built to reach another star. They were built to explore the planets of our own solar system. But once their primary missions were complete, they drifted onward, carried by momentum into interstellar space. Voyager 1 left the protective bubble of the Sun in 2012. Voyager 2 followed in 2018. They are still moving now, slowly, steadily, at a pace that feels both determined and gentle. They will not reach Alpha Centauri for tens of thousands of years, but they continue anyway, silent emissaries of a species just beginning to understand the scale of the cosmos. There is something deeply calming in that image. Two small machines drifting through the quiet between stars, their instruments mostly silent, their transmissions fading, yet their journey continuing without hurry. They are reminders that interstellar travel is not only a question of speed, but of patience. The universe operates on timescales far greater than human lifetimes. Stars live for billions of years. Galaxies spin in cycles longer than the rise and fall of civilizations. In that context, even a spacecraft drifting for tens of thousands of years feels like a natural part of the cosmos, a small steady motion within a vast ancient flow. As scientific understanding deepened, new ideas emerged, concepts for spacecraft that could travel faster, powered not by chemical engines, but by nuclear fusion, antimatter, or beams of light. These ideas were sketches of possibility, not yet realizable, but grounded in real physics. They suggested travel times not of millennia, but of centuries, perhaps even decades. And slowly, humanity began to imagine what such missions might be like. How a probe, small and light, might be pushed by a powerful light beam at a fraction of the speed of light. How it might drift through the interstellar medium, sending back faint signals as it approaches a distant star. How, one day, a mission like that could reveal the details of a world orbiting another sun. But even as these ideas grew more detailed, they remained gentle dreams of a future not yet within reach. Interstellar travel requires an understanding not just of propulsion, but of energy, materials, and the quiet hazards of space. It requires shielding from cosmic dust that could strike at high speeds. It requires navigation systems that can operate without sunlight. It requires technologies that move beyond what we have now. And so, humanity continues to imagine, to design, to explore possibilities with a sense of calm patience. The early history of interstellar thought is like the first steps on a long path. Steps taken slowly, thoughtfully, with awareness of the immense horizon ahead. Each step carries the recognition that the journey will not be completed quickly, and perhaps not by those who take the first steps, but each one also carries a quiet faith in the future, a belief that curiosity will unfold into capability, that understanding will deepen into action, that the vast space between stars will one day be crossed by machines built with intention and hope. As you let this chapter settle in your mind, you can feel how the dream of reaching Alpha Centauri has always been woven from both science and wonder. It is a dream that acknowledges distance not as a barrier, but as a truth of the universe, a truth that shapes the journey, but does not diminish it. You are drifting through that dream now, moving gently from the earliest imaginations of interstellar travel to the more detailed visions that will come in future chapters. For now, it is enough to understand where the dream began, in quiet thoughts, in soft equations, in the slow unfolding of curiosity across generations. The first engines that could carry us between the stars, as the dream of reaching Alpha Centauri drifts from imagination into possibility. The next chapter begins with a simple, quiet question. What engines could carry us across the vast, silent gulf between the stars? It is a question that unfolds slowly, like a long ribbon of thought unspooling across the canvas of the universe. To answer it, you must let your mind drift toward the frontier of technology, where ideas are still gentle sketches and possibilities shimmer faintly like distant starlight. For the engines that could take us to another sun are not the engines that lift rockets from Earth today. They are quieter things, brighter things, stranger things, machines shaped by physics at scales we do not yet command, built for journeys that last not hours or days, but decades and centuries. If you picture a spacecraft leaving Earth, you might imagine the bright, fiery plume of a chemical rocket pushing it skyward. These engines are powerful, but they are also fleeting. They burn hot and fast, using their fuel in moments, carrying a small payload into space before falling silent. Chemical rockets can take us to the moon, to Mars, even to the outer planets with careful planning. But their limits are gentle barriers, reminding us that the interstellar distances are far too great for explosions and fuel tanks. A chemical rocket could not push a spacecraft to Alpha Centauri in any meaningful span of time. Its flame would fade long before the journey had even begun. So you drift past that idea, gliding into the realm of engines that do not roar, but hum. Engines that trade brute force for persistence. Engines that breathe electricity and ionized gas. These are ion thrusters, small devices already used on several missions in our solar system. Their glow is faint, a soft blue whisper of xenon ions pushed out into space. They produce little thrust, almost nothing compared to the fiery push of a rocket launch. But they do something a chemical engine cannot. They thrust continuously. Second after second, hour after hour, month after month. Their steady, gentle push builds speed. If you imagine a leaf drifting on a quiet current, slowly gaining momentum, you begin to understand the nature of ion propulsion. Yet even ion engines, with their quiet persistence, are not enough to reach another star within a human lifetime. They shine beautifully, but lightly. To cross trillions of kilometers, a spacecraft must reach speeds far beyond what ion thrusters can provide. And so, the journey continues into deeper ideas, into technologies that have not yet been built, but which rest on firm ground in the laws of physics. One of the earliest dreams of interstellar travel was the nuclear pulse engine, a concept born from the strange, unfolding age when humanity first unlocked the secrets of nuclear energy. Imagine for a moment a spacecraft shaped like a giant disk with a long, sturdy plate at its rear, a pusher plate. Behind that plate, small nuclear charges are released one by one, each creating a controlled explosion. The shock pushes the plate, and the plate pushes the spacecraft. It is not a gentle idea, but it is a powerful one. A ship like this, known as Project Orion, could theoretically reach a fraction of the speed of light, crossing the distance to Alpha Centauri in decades rather than centuries. Scientists studied it carefully in the mid-20th century, and the numbers suggested it could work. But the idea of launching a vehicle through a series of nuclear detonations carried its own quiet risks and ethical concerns. And so the concept was set aside, its potential resting in the shadows of what might have been. Another idea drifted into view not long after: nuclear fusion propulsion. Fusion is the process that powers stars, including our sun. It is a quiet miracle of physics, light atoms merging into heavier ones, releasing enormous energy. If humans could control fusion with elegance and stability, we could build engines that shine with star-like power. A spacecraft could carry fuel in the form of deuterium or helium-3, igniting controlled fusion pulses to push it forward. The resulting speeds would be far greater than anything possible today. The distances between stars would shrink, not to moments or hours, but to spans of time that feel almost reachable. A century, perhaps, or a few decades for an unmanned probe. The idea of fusion propulsion has been explored carefully, with concepts like Project Daedalus and Project Icarus proposing giant machines built not for people, but for long, patient journeys through interstellar darkness. You can picture such a vessel now if you let your imagination stretch gently across the quiet of space. A long, slender ship with glowing engines at its stern, each pulse pushing it faster. No flames, no roar, just a steady, brilliant light, like a star moving away from you. Inside this controlled light, the ship gathers momentum, slipping quietly into the interstellar medium, its engine humming with the same power that warms the surface of the sun. Fusion propulsion remains a dream resting on the horizon, waiting for technology to catch up with theory, but its promise continues to glow softly in the collective imagination. Beyond fusion lies antimatter propulsion, one of the most powerful concepts ever conceived. Antimatter is the mirror twin of matter. When the two meet, they annihilate one another in a burst of pure energy. A spacecraft powered by antimatter would be astonishingly efficient, releasing tremendous thrust from tiny amounts of fuel. But antimatter is rare, delicate, and difficult to store. Today, we can create only small quantities of it in laboratories, and even those quantities vanish quickly. And yet, the idea remains, shimmering faintly, not as a near-term possibility, but as a beautiful expression of what physics allows. A reminder that the universe holds immense energy in the smallest of things. But perhaps the most elegant idea of all is one that does not carry fuel aboard the spacecraft at all. Instead, it carries a sail, a thin reflective sheet of material stretched wide like wings of light. A laser beam fired from Earth or from an orbiting platform pushes the sail forward. Photons, though massless, exert a tiny pressure when they strike a surface. Over time, that pressure becomes motion, and the sail begins to accelerate. Slowly at first, then more quickly, propelled by nothing but light. This concept has drawn the attention of scientists in recent years, not as a distant dream, but as a possible first step towards sending small probes to Alpha Centauri within decades. With modern materials and high-powered lasers, a tiny spacecraft could be pushed to a significant fraction of the speed of light, reaching our neighboring star system in as little as 20 to 30 years. It would not carry people, only instruments. But it would be the first true messenger from humanity to another sun. Imagine it now. A delicate craft no larger than a human hand, drifting silently through space, its sail wide and thin, glowing faintly under the push of an Earth-based beam. There is something poetic in that image. A journey carried not by engines or fuel, but by light itself. A reminder that even in the vastness of space, motion can be found in the gentlest of forces. The sail continues forward long after the laser has stopped, gliding through interstellar darkness with nothing but momentum and time as its companions. As you drift deeper into these propulsion concepts, you can feel how each one is shaped not just by engineering, but by the laws of nature. Chemical rockets embody brute force. Ion engines embody patience. Nuclear propulsion embodies power. Antimatter engines embody possibility. And light sails embody elegance. Together, they form a quiet spectrum of ideas, each one stretching toward the same distant destination, the Alpha Centauri system, glowing softly across the gulf of space. But even the most advanced propulsion concepts do not erase the challenges of interstellar travel. Space between stars contains dust, tiny grains, no bigger than flecks of sand, drifting silently in the dark. At high speeds, these grains become hazards, capable of damaging a spacecraft. Radiation from distant stars and cosmic rays can degrade electronics over decades-long journeys. Navigation requires precision across trillions of kilometers. Communication becomes faint, delayed by years. Every challenge reminds you that space is vast, beautiful, and unhurried. It rewards patience and planning, not haste. Yet these challenges do not diminish the dream. They sharpen it. They give it shape and depth and meaning. The engines humanity imagines are not just machines. They are expressions of curiosity, of persistence, of the ancient desire to explore what lies beyond the horizon. The idea of reaching Alpha Centauri remains a gentle pursuit, a long-term vision woven from science, imagination, and the quiet hope that future generations will continue the journey. As this chapter settles, you can feel the subtle shift in perspective. You have moved from the earliest imaginings of interstellar travel to the first engines that might make it possible. You have drifted past chemical rockets and ion thrusters into the realms of fusion light, antimatter brilliance, and sails carried by beams of laser light. Each idea brings you a little closer to the distant glow of another sun. And though the journey remains long, the path is becoming clearer. The universe does not rush, and neither does this story. You are drifting through it slowly, gently, with curiosity as your guide. The dream of reaching Alpha Centauri continues, unfolding with the quiet inevitability of starlight crossing the darkness, one moment at a time. Time, distance, and the human perspective. There is a quiet moment when you pause in the middle of thinking about interstellar travel, and you realize that the greatest challenge is not the engines, or the distances, or even the hazards of deep space. It is time itself. Time stretches differently when you look at it through the lens of the cosmos. Human time, measured in decades, in generations, in memories, is small and intimate. Cosmic time is slow, patient, unfolding across millions and billions of years. And when you think of reaching Alpha Centauri, you find yourself drifting between these two scales, caught in a gentle tension between the rhythm of human life and the vastness of astronomical distances. To understand what it truly means to travel to another star, you must first let go of the feeling that time is something fixed or rigid. In space, time is an ocean moving with tides and currents that stretch beyond anything familiar. Stars live for billions of years, burning quietly in cycles that far exceed the history of humanity. Galaxies revolve so slowly that even the idea of movement becomes a whisper. And against this backdrop, the span of a human life is a brief, delicate flicker, a moment of light in the long, unfolding darkness. Yet, it is precisely this smallness that makes the dream of interstellar travel feel so gentle and profound. Humans measure time not only in minutes and years, but in stories, in ambitions, in hopes passed from one generation to the next. The idea of reaching Alpha Centauri does not fit into the span of a single lifetime. but it fits easily into the larger arc of human curiosity. When you imagine a spacecraft drifting between the stars, you imagine something that continues long after its builders are gone. A continuation of thought, a thread connecting past and future across the quiet breadth of space. Consider the distances involved. Light, moving at the fastest speed allowed by nature, takes more than 4 years to reach Alpha Centauri. A spacecraft, even one powered by engines far more advanced than anything we have today, would still take decades. And if the mission were a slow one, a patient probe carried by long-lasting engines, it might take centuries. But in the scale of the universe, centuries are no more than a heartbeat. Stars drift in their orbits for hundreds of millions of years. Entire species rise and fall on planets across the galaxy. And the great spiral arms sweep slowly through space like luminous rivers. One of the most profound realizations in astronomy is that the stars we see in the night sky are not fixed points. They move slowly and silently across the heavens. Alpha Centauri itself is moving toward us, drifting through the galaxy with its own quiet momentum. In tens of thousands of years, it will be closer than it is now. And then it will drift farther away again. The galaxy is not a still image. It is a living structure, gently shifting over time. And humans, with our brief lifespans, catch only a passing glimpse of that motion. When you think about travel across these distances, you begin to understand why interstellar missions are often imagined as multi-generational journeys. A spacecraft might leave Earth with one generation and arrive at its destination with another. The people who launch the mission might never see its arrival. But they would know that somewhere, far beyond their own time, their work continues. This changes the way you think about exploration. It becomes something shared across generations, a long, quiet thread woven through time. Yet not all missions need to carry people. Machines, unlike humans, do not age in the same way. They can drift through the darkness for decades or centuries without tiring. Their perspective is not bound to the span of a human lifetime. A robotic probe sent to Alpha Centauri would not care that its journey is slow compared to human expectations. It would continue its steady flight through interstellar space, never losing its direction, never rushing, simply moving forward with the patience of the cosmos itself. When you picture such a mission, perhaps a small craft pushed by a laser sail, you might think about what it experiences not in human terms, but in cosmic ones. For the spacecraft, time is simply the succession of events, a tiny vibration in its instruments, a faint whisper of cosmic rays, the slow dimming of sunlight as it leaves the solar system behind. It drifts into interstellar space, where time feels almost suspended. Days and months lose their meaning when measured against trillions of kilometers. What matters is the movement. The slow and constant accumulation of distance, the long path toward another star. In the quiet of this thought, you begin to see that interstellar time is less about waiting and more about witnessing. It is about allowing the scale of the universe to unfold in its own way, without rushing it, without compressing it into something smaller. Humans are accustomed to speed, to planes, to cars, to digital messages that cross the world in moments. But space reminds you that not everything moves quickly. The universe was not built for haste. Its stories are measured in vast sweeps of time, in gentle shifts, in patient rhythms. When astronomers think about time, they think not in minutes, but in light years, in the way light stretches across space, carrying the memory of distant events. The light from Alpha Centauri that reaches your eyes tonight left the star system years ago. It traveled through the interstellar medium, passing dust clouds and magnetic fields, taking its time, moving steadily. In a way, when you look at Alpha Centauri, you are looking slightly into the past, not far, but far enough to remind you that time behaves differently in the cosmos. And yet, even with this vastness, there is something intimate about interstellar time. It folds into human thought in a way that feels almost comforting. Humans tell stories about journeys, about travelers crossing unknown lands, about voyages that span great distances. Interstellar travel is simply the grandest version of that story, a journey not across oceans or continents, but across the silent sea of stars. And though the distance is immense, the idea carries a familiar warmth. It is the same human impulse that once pushed explorers across Earth, now stretched across the galaxy. As you drift deeper into this thought, you can sense how time becomes not an obstacle, but a presence. It is something you move with, not against. A spacecraft traveling to Alpha Centauri would be like a message written across centuries, a quiet testament to a moment in human history when curiosity reached beyond the solar system. Even if the mission lasted 100 years, it would still be only a blink in the life of the galaxy. There is a gentle beauty in this realization that interstellar travel does not need to fit into a human lifetime to be meaningful. It simply needs to belong to the unfolding story of humanity. Just as ancient astronomers charted the stars, knowing they would never reach them. Just as early explorers set out on journeys they knew they might not complete. Modern scientists propose missions that span generations. Each generation adds to the journey, contributing its knowledge, its dreams, its quiet determination. When you think about time this way, the distance to Alpha Centauri begins to feel less daunting. It becomes part of the universe's natural scale, something that fits within the long arc of cosmic history. Human life is brief, but human curiosity is long-lived. It stretches through time like a continuous thread passed from one generation to the next. And interstellar travel, with its vast distances and slow progress, is simply the next place for that thread to reach. As you let this chapter close gently in your mind, you may find yourself thinking not of the distance between stars, but of the continuity between moments. The journey to Alpha Centauri begins in the present, but it extends far beyond it, into a future shaped by many hands and many minds. It is a journey of time as much as distance, a drift through the ages, carried by the soft persistence of curiosity. And in that drift, you find a quiet place where the human perspective meets the vastness of the cosmos, not in fear or urgency, but in a calm, steady understanding of the way the universe unfolds. The story continues, not with haste, but with patience. For in the gentle rhythm of cosmic time, there is space enough for every journey, even the one that leads to another star. Through the quiet sea, between the stars, there is a moment. Once a spacecraft leaves the warmth of the solar system, when the familiar boundaries begin to fall away. The sun grows smaller in its wake. The planets fade into memory. The scattered dust of the Kuiper Belt thins into a cold, delicate haze. And then, at last, the spacecraft crosses an invisible frontier, the edge of the sun's influence, and enters the quiet sea of interstellar space. This is a place unlike any other, a realm so still and so immense that time itself feels softer, stretching into something almost weightless. As you imagine this crossing, you drift with the spacecraft, moving slowly and steadily into the true night between the stars. Interstellar space is not empty. It only feels that way because of scale. In every cubic meter, there may be a single atom. A single grain of dust might float across kilometers of distance before encountering another. The silence here is not a lack of sound, but the absence of anything to carry it. The cold is not the cold of winter, but the almost perfect chill of a place far removed from the warmth of starlight. This is the environment that lies between the suns of the galaxy, a dim, delicate ocean of near-nothingness stretching in all directions. If you picture yourself drifting alongside the spacecraft, you see nothing but darkness punctuated by stars. The sun now appears as a bright but distant point, one star among many. Its light no longer dominates. Its warmth no longer reaches. The spacecraft continues forward on momentum alone, carrying within it the echoes of the civilization that built it. Here, in this immense quiet, the journey begins to feel different, less like a voyage through space and more like a passage through time. The interstellar medium, though thin, is full of character. Hydrogen atoms drift like slow-moving grains of fog. Traces of helium, oxygen, and carbon move silently along magnetic field lines that thread the galaxy like invisible embroidery. Cosmic rays, particles accelerated by ancient supernovae, pass through the darkness with ghost-like precision, sometimes slipping through the spacecraft itself. In this place, even the faintest energy has come from far away. The darkness is not lifeless. It is simply patient. Occasionally, the spacecraft may encounter a cloud of interstellar dust, the same tiny grains that once drifted through nebulae where stars were born. These grains are relics of ancient worlds, remnants of stars that lived and died long before the Earth formed. Dust here is not like dust on Earth. It is microscopic, intricate, shaped by processes too slow to witness. Some particles carry frozen water, some carry carbon chains, some carry metals forged in supernova explosions. And as they drift past the spacecraft, each particle holds a story billions of years old. The journey through interstellar space is long, but length itself becomes a kind of calm. There is no urgency here, no turbulence, no change in scenery. The spacecraft moves through the same dark environment day after day, year after year, decade after decade. In this constancy, there is a strange beauty. The universe, usually seen from the surface of a planet, filled with motion and change, reveals its quieter nature, a nature shaped by vastness, by stillness, by time measured in light years. If you imagine the spacecraft sending signals back to Earth, those signals would take years to arrive. Each transmission is a message stretched across distance and time. A tiny flicker of data travels through space, passing dust clouds, slipping between magnetic fields, crossed by wandering particles. By the time it reaches Earth, the spacecraft will have traveled millions of kilometers farther along its path. Communication becomes a kind of memory, each signal a snapshot of what once was. But as the spacecraft continues drifting, something subtle begins to happen. The stars themselves begin to shift slightly, almost imperceptibly. Their positions, fixed from the perspective of Earth, bend gently as the spacecraft moves closer to some and farther from others. Constellations that seem eternal from the ground start to dissolve and reform. This change is slow, too slow for a human eye to notice in a single lifetime. But the spacecraft, moving steadily through the galaxy, becomes a witness to the gentle drift of the stars. In this slow reorganization of the sky, you feel the presence of scale. The galaxy is not frozen. It is alive with motion. Stars orbit the galactic center at different speeds, drifting along paths shaped by gravity and time. Some move toward one another, some drift apart. The Milky Way is a vast, rotating river of suns, and the spacecraft, though tiny, moves with it, carried by the currents of galactic motion. Eventually, the spacecraft may pass through regions of slightly denser material, not clouds, but gentle ripples of gas and dust. These are the wakes of long-dead stars, the remnants of ancient supernova shocks, or the faint signatures of gravitational tides created by passing stars. In these regions, the density increases only slightly, perhaps 2 atoms per cubic meter instead of 1. But even such small changes become meaningful when the environment is otherwise so subtle. The temperature of interstellar space is almost unimaginably cold. Away from the sun, away from any nearby star, the spacecraft drifts through a darkness illuminated only by the faint afterglow of the Big Bang, the cosmic microwave background. This ancient radiation, stretched by billions of years of expansion, bathes the universe in a gentle warmth of just 2.7 degrees above absolute zero. It is a temperature not of winter, but of eternity. A temperature set by the age of the cosmos itself. And the spacecraft carries this cold with it, a quiet signature of its distance from all sources of heat. As you imagine this journey, you begin to understand that interstellar space is not simply the space between destinations. It is an environment of its own, with its own character, its own rhythm, its own subtle structures. It is a place where time stretches so far that distance becomes almost irrelevant. A place where the movement of the spacecraft feels less like progress and more like drifting through a cosmic stillness. Sometimes, the spacecraft might pass a lone star wandering the outskirts of a spiral arm. Most stars have companions or belong to clusters, but some drift alone, carried by ancient trajectories. Their light spills gently across the darkness, illuminating dust grains that float in their path. These stars may lie far off the direct route to Alpha Centauri, but even from a distance, they remind you that the galaxy is not empty. Its stars, though separated by vast distances, form a network of light stretching across the entire spiral disk. There may also be rogue planets, worlds that formed around stars but were later cast out by gravitational tides. These planets drift silently through interstellar space, frozen and dark, their surfaces cold enough to harden entire oceans. If the spacecraft were to pass near one, it would see nothing at first, only a circular absence of starlight, a faint gravitational tug, and perhaps the dim glow of heat escaping from deep within the planet's core. These worlds are rare and difficult to detect, but they exist, scattered throughout the galaxy like forgotten stories. As the spacecraft continues, Alpha Centauri grows slowly brighter. It does not appear dramatically, but gradually, over decades, becoming a clearer point of light, a warmer presence in the darkness. Its glow blends with the faint luminosity of the interstellar medium, guiding the spacecraft forward like a distant lighthouse on the edge of a quiet sea. And though the distance remains immense, the sense of destination begins to deepen. Somewhere within its memory, the spacecraft carries the echoes of Earth, the commands of its builders, the patterns of its sensors, the faint residue of the world it left behind. But out here, in the vast quiet between stars, it is no longer a machine tied to a single place. It has become a traveler of the galaxy, moving through a realm where distance feels infinite and time expands into something serene. And you, drifting alongside it in your imagination, begin to feel the quiet dignity of this journey. The spacecraft is small, but it carries the intention of a civilization. It moves slowly, but its path stretches across the architecture of the galaxy. It experiences almost nothing, yet each moment is part of something vast, a voyage through an environment that most beings will never see. Interstellar space is not a void. It is the quiet stage upon which stars live their long, luminous lives. It is the dark canvas upon which galaxies paint their spirals. It is the ocean through which every star, planet, and wandering world drifts. And as the spacecraft travels through it, it becomes part of that quiet story. A faint, persistent motion through the oldest and most silent region of the cosmos. The journey continues, not with excitement or urgency, but with a calm acceptance of scale. For between the stars, even time seems to drift like dust, carried gently by the quiet currents of the galaxy, the first light of another sun. There comes a moment, after decades of drifting through the quiet dark between stars, when the blackness begins to change. It happens slowly at first, so subtly that even a sensitive instrument barely notices it. A faint increase in the density of charged particles. A slight warming of space measured only in fractions of a fraction of a degree. A shift in the orientation of magnetic fields so gentle that it feels more like a breeze than a boundary. And then, after years of patient motion, the spacecraft finally begins to sense something new. The first touch of a different star's presence. It is the earliest whisper of the Alpha Centauri system, carried across the emptiness like the first pale light of dawn brushing against the edge of night. For so long, the journey has been defined by silence, by a darkness that was calm and unbroken. But here, at the threshold where interstellar space begins to yield to the reach of another sun, the environment changes its tone. You can imagine the spacecraft gliding forward with the same quiet determination it has held since leaving Earth, its sensors reaching into the dark and feeling the first signs of arrival. The particles that once drifted sparsely through the void now grow slightly more numerous. Their direction shifts, guided not by the faint collective winds of the galaxy, but by the focused outflow of the Alpha Centauri stars. After all this time, the spacecraft has entered another stellar system's outskirts, a place still cold and vast, but no longer untouched. If you drift alongside the spacecraft in your imagination, you might notice how the light ahead has grown just a little brighter. For decades, the Alpha Centauri system has appeared only as a set of distant points, no different from the countless stars scattered across the sky. But now, those points begin to sharpen, to grow, to take on the faintest nuance of color. Alpha Centauri aglows with a warm, golden hue, similar to the sun, but slightly more luminous. Alpha Centauri b shines with a gentler, orange light, dimmer but steady. And far off to the side, barely visible, Proxima Centauri flickers with the cool, soft red of a quiet dwarf star. The spacecraft is still far away. Trillions of kilometers remain, but the difference is no longer one of abstraction. It is real. The system ahead has presence. Its light, though faint, carries warmth. Its particles carry motion, and its gravity, subtle but undeniable, begins to pull gently on the spacecraft's path. This is the first true sign that the long drift through the void is giving way to the slow, unfolding welcome of a new stellar neighborhood. At this distance, the boundary the spacecraft crosses is not a sharp line, but a gradual transition. Around every star lies a region shaped by stellar wind, a stream of charged particles flowing outward through space. The sun's wind created the heliosphere, the bubble the Voyager probes crossed years ago. Now the spacecraft begins to enter the outer whispers of the Alpha Centauri equivalent. This boundary, an analog to the heliopause, marks the place where the winds of the twin stars balance against the soft pressure of the interstellar medium. Crossing it is like sailing from one ocean into another. The water may look the same, but the currents shift, the temperature changes, and the silence gains a new tone. Here, the stellar wind is faint, stretched thin by distance, but it marks the presence of the stars ahead. It is the first physical sign that the spacecraft has left one domain and entered another. As you drift through this region in thought, you may imagine the stars ahead beginning to separate themselves from the background sky. Slowly, gently, their colors grow more distinct. Their motions, once imperceptible, become subtle arcs. Alpha Centauri A and B circle each other in a long, elegant orbit lasting more than 70 years. Their gravitational dance is slow, but from this vantage point, you can sense its rhythm. Two suns bound by a shared motion, guiding each other with a soft pull of gravity. Their light mixes across their system, casting overlapping patterns of illumination that paint the surrounding space in hues of gold and amber. Further away, Proxima Centauri orbits the pair with extreme patience. Its path is long and distant, its motion so slow that an entire human civilization could rise and fall before its orbit completes. Yet even here, at the very edges of the system, its presence is felt. Its faint glow adds a touch of red to the sky ahead, a gentle contrast to the warmer tones of its larger companions. As the spacecraft continues forward, the density of particles carried by the stellar wind increases, still sparse but clearly rising. Measurements show fluctuations in magnetic fields, ripples caused by the outflow of the stars. The solar-like wind from Alpha Centauri A merges with the quieter, cooler wind from Alpha Centauri B, forming a gentle, shifting pattern in space. A pattern the spacecraft now moves through. These winds have traveled millions of kilometers, carrying the faint imprint of their star's character. They are the breath of another world, touching the spacecraft long before its instruments ever sense the true warmth of the stars. In the darkness surrounding all of this, the background sky begins to change. Constellations, once familiar, have subtly altered. From this vantage point, the angle of Earth's sky no longer matches the patterns you know. The Southern Cross has shifted. The Centaurus constellation stretches differently. Stars that once appeared fixed in familiar shapes have moved slightly, their positions whispering the truth that every star is in motion, drifting through the galaxy in slow, graceful arcs. The spacecraft sees the night sky as no human eye has ever seen it, from a perspective displaced by light years, a perspective shaped not by Earth's orbit, but by a journey across the interstellar sea. As the light of Alpha Centauri grows stronger, the spacecraft becomes bathed in a dim glow, unlike anything it has experienced since leaving the solar system. It is not bright, not yet, but it is warm in its own quiet way. A signal of arrival, a reminder that stars are not only distant points, but sources of life, warmth, and gravity. The spacecraft moves toward them like a traveler approaching the faint lights of a distant shore. Each day, the glow increases, imperceptibly but steadily, revealing the long arc of its path. Instruments on the spacecraft detect changes in radiation. They sense the signature of stellar activity, the quiet storms of Alpha Centauri A, the softer rhythms of Alpha Centauri B, and the occasional flare from Proxima Centauri. Every star has its own temperament, expressed through the patterns of its light and wind. The spacecraft reads these signals like soft pulses in the dark, each one a heartbeat from a world it has not yet reached. As distance continues to shrink, the spacecraft begins to detect the gravitational pull of the individual stars with greater clarity. Their mass shapes the space around them, creating a landscape of invisible valleys and slopes. The spacecraft glides along these curves, guided not by engines, but by the elegant geometry of gravity. Space is not empty here. It is shaped by the gentle hands of 3 stars, each contributing to the tapestry of motion. Eventually, the Alpha Centauri system grows large enough that its internal structure becomes visible. Alpha Centauri A and B, once just 2 points of light, now appear distinct, their colors more pronounced. Their orbit becomes clearer, a slow loop of motion that will continue long after the spacecraft arrives. Proxima Centauri, small and dim by comparison, lingers on the edge of sight. Its red glow faint but steady, like a quiet lantern watching from afar. This is the moment when the spacecraft's long journey gains meaning, when the destination becomes more than a theoretical point on a map. It becomes a real place with real light, real energy, and real depth. For decades, the spacecraft has drifted in near-perfect darkness. Now it moves toward the soft glow of a new sun. And you, drifting with it in your imagination, feel the shift as well. But the journey no longer feels endless. It no longer feels defined solely by distance. It feels like an approach, a gentle arrival at the boundary of another world's domain. The universe is still vast, still quiet, still patient. But here, at the edge of Alpha Centauri, there is also warmth. There is color. There is motion. There is the first light of another sun. The journey continues, and the darkness that once stretched endlessly now begins to open into something new. A dawning landscape of starlight, waiting to be explored. Beneath the twin suns of Alpha Centauri, as the spacecraft travels deeper into the Alpha Centauri system, the 2 primary stars begin to reveal themselves with a clarity that no telescope from Earth could ever match. What were once distant points of light now grow into true suns, each carrying its own warmth, its own character, its own quiet presence in the dark. Alpha Centauri. Eye shines with a golden radiance, slightly brighter than the sun, you know, its light steady and strong. Alpha Centauri B glows beside it in softer tones of amber, a gentler companion circling in a long, elegant orbit. Together, they form a pair unlike anything seen from Earth. 2 suns bound in a silent, gravitational dance, their light overlapping like the blended colors of dawn. You can imagine the spacecraft drifting into this new, stellar neighborhood, watching as the glow of the twin stars deepens. Their combined light paints a faint path across the surrounding dust, illuminating particles that have drifted here for millions of years. Each particle carries a history. Pieces of ancient collisions, fragments of long-dead planets, grains of carbon formed inside stars that lived and died before the Alpha Centauri system itself was born. The spacecraft moves through this gentle haze, its sensors capturing the quiet story of a system shaped by time. From this vantage point, the relationship between Alpha Centauri A and B becomes clear. They orbit one another in a wide ellipse, moving with the calm assurance of bodies that have repeated the same motion for billions of years. Sometimes they drift closer, their light blending into a warm, unified glow. Sometimes they drift apart, each shining with its own distinct hue. Their orbit, lasting roughly 80 years, is slow enough that the spacecraft would witness only a small part of it during the approach. But even that small part feels immense, like watching the minute hand of a cosmic clock move by a single notch. The gentle warmth of the twin stars creates a complex environment. Their combined gravity shapes the space around them, carving paths where planets might form, creating regions where dust collects into belts, and areas where orbits remain stable for generations. Although Earth-based telescopes have searched for planets around these stars for years, none have yet been confirmed. Still, the possibility remains. In the soft light of Alpha Centauri A and B, planets, if they exist, would experience days lit by two suns, their skies cast in colors unfamiliar to Earth. Shadows would split softly in different directions. Horizons would glow not with one rising star, but with two, their golden hues interweaving across the surface of any world fortunate enough to circle them. Even without confirmed planets, the Alpha Centauri system is far from empty. Dust bands extend through the region like faint golden rivers. Streams of particles drift around the stars, shaped by their gravity and their winds. Occasionally, the spacecraft's instruments detect small objects, tiny rocky bodies or fragments of ancient collisions drifting quietly in stable orbits. These objects are too small to be called planets, too irregular to be moons, yet they are part of the system's architecture, silent markers of the processes that shape stellar neighborhoods. As the spacecraft travels farther inward, the light of Alpha Centauri A grows brighter. Its spectrum is almost identical to that of the Sun, and yet there is a difference you can feel in the tone. The light is faintly warmer, subtly deeper, touched by a character that belongs only to this star. Its surface churns with convection, rising and falling in slow, powerful cycles that create patterns of brightness across its photosphere. Magnetic fields twist and relax, sending soft waves of energy outward across millions of kilometers. The spacecraft detects these fluctuations, not as turbulence, but as a kind of stellar breathing, a rhythm carried through space. Beside it, Alpha Centauri B shines with a slightly different voice. Its light is dimmer, its temperature lower, its activity more subdued. We're Alpha Centauri. A expresses itself with golden brightness. B glows with quiet warmth, like an ember beside a flame. Together they form a balanced pair, one lively, one calm, moving through the galaxy with shared purpose. As the spacecraft approaches the inner region of their system, the brightness of the stars creates a new sensation, almost as if interstellar space is opening into a realm of gentle illumination. For decades, the spacecraft has known only darkness punctuated by distant points. Now, the darkness softens. Shadows shorten. The glow of starlight begins to shape the surrounding environment. Even dust particles take on new color, reflecting the gold and amber of the twin suns. The sense of arrival deepens. Yet something remains absent from the sky ahead. Proxima Centauri. The small red dwarf lies far to the side, orbiting its sibling stars at a distance of more than 1 trillion kilometers. Its presence feels separate, almost solitary, as if it watches from the outer edge of the system with a quiet patience. From this interior vantage point, Proxima's glow is barely a spark, a dim red ember lingering in the distance. But even that faint light carries a story the spacecraft will soon approach, as the chapters ahead drift toward the cool red realm of Proxima B. For now, though, the spacecraft remains within the influence of Alpha Centauri A and B. It listens to the soft hum of their combined stellar winds. It feels the push and pull of their gravity guiding its trajectory. It watches as their light paints the surrounding space sunset in soft gradients of gold. As you drift through this scene in your imagination, you might notice how the beauty of a binary star system differs from that of a solitary sun. On Earth, the sun dominates your sky. It is the center of warmth, of day, of the rhythm of life. But here, that role is shared. If a planet orbited these stars, its sky would hold two centers of light, each rising and setting in slow choreography, each shaping the world's illumination in its own way. Some nights would be darker than others, some days brighter. Shadows would dance with overlapping patterns. The seasons, if they existed, would be shaped by two suns moving in tandem. It is a kind of beauty unfamiliar to Earth, but natural here, where duality replaces singularity. This duality also shapes the space through which the spacecraft moves. Stellar winds from both stars meet and merge, creating complex patterns of plasma flow. Their magnetic fields interact, forming regions of turbulence and calm. The spacecraft sails through these invisible landscapes, its sensors reading the shifting currents like a traveler learning the contours of a new sea. As Alpha Centauri grows closer, the sense of motion changes once more. The journey no longer feels like drifting through endless silence. It feels like approaching a destination, one defined not by terrain or atmosphere, but by light. The stars ahead are no longer distant goals. They are companions, illuminating the path with increasing warmth. In these moments, the spacecraft becomes something more than a machine. It becomes a link between two star systems, an emissary of human curiosity carried across the gulf of space. It sees the Alpha Centauri system from a vantage point no living being has ever held. It experiences the light of another sun not as a distant shimmer, but as a steady glow guiding its path. And you, moving with it in thought, feel the quiet significance of this arrival. For the first time in the history of your species, something built by human hands has entered the domain of another star. It is a moment that unfolds not in fanfare or haste, but in silence, in patience, in starlight slowly brightening across the surface of a distant machine. The twin suns of Alpha Centauri shine ahead, steady and beautiful, each pulse of their light carrying you deeper into this new world. The journey continues, unfolding gently beneath their glow. Proxima Centauri, the quiet star on the edge. As the spacecraft drifts farther from the warm embrace of Alpha Centauri A and B, a subtle shift begins to unfold across the darkness. The twin suns grow smaller behind it, their golden and amber light becoming two soft glimmers rather than the luminous pair that filled the sky moments ago. Ahead lies a different kind of glow, dimmer, cooler, quieter. It is the faint red light of Proxima Centauri, the smallest and most unassuming member of the system, orbiting the twin stars from an immense distance. For a long time, the spacecraft has seen Proxima only as a soft ember in the far background. Now, that ember grows slightly brighter, its presence no longer just a background note in the sky, but the destination of this patient drift across a foreign stellar neighborhood. Proxima Centauri is a red dwarf, a star so small and cool that it emits most of its energy in the red and infrared portions of the spectrum. To the human eye, it would shine not with the intense radiance of the sun or the rich gold of Alpha Centauri A, but with a quiet ruby glow, a delicate point of warmth suspended in the cold. Red dwarfs are the most common stars in the galaxy, yet they hide in the shadows of brighter suns. They are the quiet keepers of long time, burning their fuel slowly, carefully, across trillions of years. Proxima has already existed longer than the sun, and it will likely continue burning long after brighter stars have faded into white dwarfs. It is a star built for endurance, for silent persistence, for patience. A fitting destination for a spacecraft that has crossed such an immense expanse of time and space. As the spacecraft approaches, the environment changes in subtle ways. The density of dust and gas shifts. The light ahead becomes less warm, more muted, like the fading glow of a distant lantern. The star is faint, but its influence stretches far. Its gravity, its magnetic fields, its soft winds gently sculpt the space around it. If you drift beside the spacecraft in your imagination, You might notice how the sky darkens even as Proxima grows brighter. The twin suns are far behind, too distant now to cast meaningful light. The region around Proxima feels different, not empty, but calm in a new way, cooled by the soft red glow spilling outward from a star no larger than a planet like Jupiter. The spacecraft's instruments begin to detect the signature of Proxima's stellar wind, a slow, cool outpouring of charged particles moving outward into the void. Unlike the sun, which flares in bright bursts of energy and light, Proxima's activity pulses in bursts that are more unpredictable. Red dwarfs are known for their flares, sudden eruptions of magnetic energy that send waves of radiation across their systems. Even small stars carry powerful tempers hidden beneath their quiet glow. The spacecraft feels these bursts not as danger, but as patterns. Variations in particle flow, small surges in radiation, soft ripples across the magnetic field. Each flare tells a story about the star's interior, about the complex motion of plasma beneath its surface. But perhaps the most intriguing aspect of Proxima Centauri lies not in the star itself, but in the small, rocky world that orbits close to it. A planet called Proxima b. The spacecraft has known of its existence since before launch, but only now does the journey bring it into a region where the planet's presence feels real. No longer a distant point inferred from starlight, but a world that exists somewhere ahead, hidden in the dim glow of its parent star. Proxima b is roughly Earth-sized, orbiting in the region scientists call the habitable zone, the distance where temperatures could, in theory, allow liquid water to exist. But its orbit is close, far closer than Earth's is to the Sun. It completes a year in just 11 days, locked in a gravitational embrace that keeps one side facing the star at all times, leaving one hemisphere bathed in perpetual red daylight and the other in endless darkness. As the spacecraft drifts closer, the idea of this world becomes vivid. Picture a place where the sky glows with a dim red light, where shadows stretch long and deep, where the star never rises or sets, but hangs motionless in the same place, painting the landscape with a steady, muted glow. The daylight side of the planet may be warm, its surface gently heated by the cool radiance of Proxima. The dark side may be frozen, its plains and mountains cloaked in eternal night. Between them lies the Terminator, a twilight band where day meets night, a zone that could be neither too hot nor too cold. If life exists here, it might flourish in this narrow region, adapting to the soft red sun that dominates the sky. But no one knows what Proxima b truly looks like. Its air, if it has an atmosphere at all, remains a mystery. Its surface composition, its oceans, or rocks, or plains, its winds and storms and temperature, all are unknown. What the spacecraft carries toward it is not certainty, but wonder. The journey is not an attempt to touch the planet or land on it. It is simply an approach, a gathering of data, a quiet observation from afar. The spacecraft is too small to enter orbit or to descend. But even a single glimpse, a single measurement of its atmosphere, a single silhouette of its surface against Proxima's faint light, any of these would be a revelation. As the spacecraft draws nearer, Proxima's light grows strong enough to cast a faint glow across its surface. Not bright, not warm, but visible. A red illumination that softens the darkness. The star flickers occasionally, its brightness changing in subtle pulses that ripple outward across space. These pulses give the spacecraft new information, clues about the star's activity cycles, its magnetic storms, its patterns of behavior. Each pulse is like a quiet heartbeat, a sign that even the smallest star has a living, dynamic interior. Proxima's presence reshapes the constellations once more. From this vantage point, the positions of familiar stars shift again, their alignments bending and stretching as the spacecraft crosses into a region of space seen by no human eye. The twin suns of Alpha Centauri appear far behind, small but still visible. 2 points of gold and amber that remind the spacecraft of the world it passed through. Ahead, the sky dims into shades of deeper blue-black, punctuated by Proxima's small but steady glow. If you imagine orbiting Proxima b, the sky would hold 3 suns, Proxima itself at the center, glowing constant and red, and far off on the horizon, Alpha Centauri A and B shining together in a brilliant pair. On certain nights, when Proxima flares, its light would brighten the entire landscape, casting long red shadows across rocks and valleys. On the nights when its flares fade, the distant twin stars would provide a pale golden shimmer from afar. It is a system unlike the sun's, bound not by the familiar rhythm of a single star, but by the complex interplay of 3. As the spacecraft enters the heart of Proxima's domain, it begins to feel the gravitational well of the planet. Not strong, just a subtle pull, a whisper that marks the presence of a world orbiting in quiet harmony with its small star. The spacecraft adjusts its angle slightly, orienting its instruments toward the region where Proxima b travels in its 11-day loop. Light reflected from the planet, faint and stretched to the edge of detection, reaches the spacecraft's sensors. The signal is delicate, almost lost in background noise, but it is enough to confirm the planet's presence. A world exists here, circling a star too small to be noticed by most telescopes from Earth. In the silence of this moment, the vast purpose of the journey becomes clear. Humanity, from its small blue world orbiting a single sun, has extended its reach into a realm of 3 stars and multiple worlds, some known, some unknown. The spacecraft, tiny against the scale of the cosmos, drifts into a region no craft has ever entered. It becomes an observer of a system that has existed for billions of years without being touched by human thought. And now, for the first time, it is no longer alone. A machine carrying the curiosity of an entire species approaches a star that has glowed untouched in the quiet of deep time. As Proxima Centauri grows brighter, the spacecraft continues its steady approach. Its sensors open, its instruments ready to capture whatever faint signals the star and its planet reveal. The long journey from the sun to another star has moved beyond abstraction. It has become a reality, unfolding one quiet moment at a time beneath the cool red glow of the galaxy's most common kind of sun. And as you drift with it in your imagination, Proxima's soft light touches the edges of your vision too, an ancient glow that has burned for longer than human history, welcoming its first visitor from afar. The journey goes on, deeper into this quiet corner of the galaxy, guided now not by distant memory, but by the gentle, steady light of Proxima Centauri. Proxima b, the quiet world in the red light. As the spacecraft drifts ever closer to Proxima Centauri, a subtle shift occurs, not in the star itself, but in the darkness around it. Space no longer feels like an endless expanse of silence. It begins to feel like a place with structure, with depth, with direction. Every faint pulse of radiation, every subtle fluctuation in magnetic fields, every whisper of particles carried on Proxima's subdued stellar wind gives shape to the space ahead. And gradually, the spacecraft's sensitive instruments begin to detect something else. An intermittent rhythm of shadows, patterns in the dim red light that hint at the presence of a world circling in the quiet glow of its small star. This world is Proxima b. For most of its journey, Proxima b has existed only as a mathematical certainty, a gravitational tug observed from afar, a periodic dimming in a star's light. But now, the spacecraft approaches the region where the planet completes its swift orbit every 11 days. The world remains invisible to the naked eye. Too small, too dark, too distant from any source of bright illumination. But the instruments begin to feel its presence like a faint echo, a slight wobble in the stellar wind, a temporary thinning in charged particle density. These delicate traces mark the position of a rocky planet moving silently through its orbit, forever locked in the gentle pull of its red sun. You drift through this realization softly, letting the image of Proxima b unfold in your mind. It is a world unlike Earth, yet somehow familiar in its potential. Around a star with only a fraction of the sun's energy, Proxima b must cling tightly to what heat and light it receives. To remain in the habitable zone, the delicate region where liquid water might exist, the planet orbits extremely close to Proxima Centauri. Its year is only 11 days long, and its face is tidally locked, with one hemisphere always bathed in the star's muted light and the other frozen in eternal night. Imagine standing on the daylight side of Proxima b. The sky above you is not blue, but a deep crimson, painted by the soft radiation of the red dwarf. The star hangs fixed in the sky, its position unmoving, like a lantern suspended in the heavens. Its glow is gentle, almost comforting, yet unsettling in its constancy. Shadows stretch long and sharp across the ground. Colors around you appear muted, washed in red. The warmth you feel is soft but steady, not the bright heat of an earthly noon, but a low, persistent warmth that seeps slowly into the landscape. If Proxima b has an atmosphere, and no one yet knows if it does, the winds would circle endlessly between day and night. On the day side, warm air rises softly, flowing upward in slow currents. It glides across the terminator, cooling as it travels toward the night side, where it sinks into the darkness before returning again toward the dawn. This constant motion would create a twilight band, a ring of perpetual dimness encircling the planet, where temperatures might be stable, neither frozen nor overheated. It is within this twilight zone, the eternal boundary between day and night, that life, if it exists, might find its most gentle refuge. But if the planet lacks an atmosphere, the picture becomes starker. The day side might be scorched by Proxima's occasional flares, while the night side sinks to temperatures colder than the emptiest corners of interstellar space. The surface would be silent, barren, marked by sharp contrasts, sunlit deserts and frozen voids, separated by nothing but a thin, silent horizon. The spacecraft, drifting steadily toward the region of Proxima b's orbit, seeks answers to these questions. Its instruments stretch outward like delicate senses, scanning for faint absorption lines in Proxima's light, signatures that might reveal whether gases like oxygen, carbon dioxide, water vapor, or methane encircle the planet. Each line detected would be a clue, a whisper of the planet's true nature. But the signals are faint, blending into background noise, requiring patience and repeated measurements. And still, Proxima b remains unseen. The world reveals itself not through its surface, but through its influence. How it shapes the light around it, how it bends the thin winds of its star, how it tugs gently at the spacecraft's instruments as it passes near. In this subtle interaction, a portrait begins to emerge. Not a detailed image, but an impression, a quiet sense of the planet's presence. You may imagine Proxima B's orbit now as a dark path circling a calm red star. The spacecraft glides through this orbit at a distance far above the planet itself, observing its motion from the emptiness around it. Below, the world moves through its phases, day, night, twilight, in a rhythm far slower than the shifting sky of Earth, but far faster than the slow movements of Alpha Centauri A and B. On the day side, if clouds exist, they may gather in soft formations, colored in shades of red and copper, illuminated from beneath by Proxima's muted glow. On the night side, auroras might shimmer, vast curtains of electric light shaped by the star's magnetic storms, drifting silently across the frozen landscape. These are only possibilities, but even the possibilities carry beauty. The night side of Proxima B holds mysteries that stretch beyond imagination. Locked away from sunlight, it might be a realm of deep cold, with landscapes sculpted by ice harder than steel. Mountains could rise in the darkness, shaped by geological forces unlit by any star. Oceans, if they exist, might lie frozen on the surface, with liquid water preserved far below. This hemisphere is a silent place, illuminated only by the occasional flare-driven aurora or the distant glimmer of Alpha Centauri A and B on the horizon, appearing as two shining stars far from home. Between these extremes lies the terminator, the twilight zone. Here, the temperature might hover at the edge of comfort. Here, a person could stand at the boundary between eternal day and eternal night. One horizon would glow in red daylight. The other would fade into darkness. Shadows would stretch endlessly in one direction. The sky would hold a single unmoving sun. And if life exists, it might flourish here, in the climate-stabilizing balance of light and dark. Yet the spacecraft does not descend. It does not land or orbit. It simply observes, drifting patiently past the region of Proxima B's orbit, gathering faint signals, recording soft impressions. It watches the small red star turn slowly, feels its winds wash gently over its structure, senses the planet's presence like a whisper beneath the hum of the cosmic background. Here, at the heart of the system, the journey deepens. The spacecraft has traveled across a gulf so vast that even the concept of distance seems delicate. And now, in this quiet orbit around a cool red star, it witnesses a world that may hold answers to questions humanity has asked for centuries. Are there places beyond Earth where conditions might allow life? Could worlds orbiting small, quiet stars hold oceans, atmospheres, seasons, stories of their own? The answers remain faint, carried in the subtle signals the spacecraft detects as it continues its approach. But even without certainty, the moment feels profound. For the first time, a messenger from Earth has drifted into the intimate domain of an alien world, one that has never known the warmth of the sun, one that has existed in quiet secrecy for billions of years. As the chapter closes, the spacecraft continues its slow movement through Proxima's orbit, guided by nothing more than its momentum and the faint pull of the star. Ahead lie puzzles still unsolved, patterns in the planet's light, echoes of its atmosphere, shadows that may reveal its landscape. And you, drifting beside it in thought, feel the calm of this moment. A distant world circles a small red sun, untouched, unknown, waiting in silence. And for the first time in human history, something has come close enough to listen. The meaning of a distant world, There is a moment in every long journey when distance gives way to reflection. As the spacecraft drifts through the orbit of Proxima b, having crossed a gulf so vast it once seemed beyond imagination, the meaning of the voyage begins to unfold in a new and quieter way. The planet circles its dim red star with the calm regularity of a world untouched by human thought, unaware that something from another sun now shares its sky. For billions of years, Proxima b has turned beneath the muted glow of its star, alone in the darkness. And now, for the first time, a small machine born in a distant solar system glides near, listening, observing, bearing witness. The spacecraft cannot speak, but its trajectory says everything. A message sent across interstellar time, telling the universe that humanity once existed, once wondered, once reached beyond its cradle and touched the space around another star. You can imagine the quiet dignity of this motion. No applause, no ceremony, no witness except the star itself and the silent world turning beneath it. Yet the significance is profound, echoing far beyond the spacecraft's small frame. Proxima b does not reveal its secrets easily. It remains a silhouette in the red glow of its parent star, its atmosphere, if one exists, hidden in the delicate distortion of light passing through its edge. The spacecraft's instruments strain to detect even the faintest indication of molecules swirling in the planet's air. A small shift in wavelength might reveal water vapor. A slight dip in intensity might indicate carbon dioxide. An unusual pattern might suggest something more exotic, something that hints at processes unfolding far from Earth. But nothing is certain. The signals are faint, delicate, slipping between the stars like whispers carried on a breeze. Even without clarity, the possibility alone carries weight. For the first time, humanity stands on the threshold of knowing. Not imagining, not hoping, but knowing. Whether a nearby world might hold the conditions for life. Even if Proxima b is barren, its existence marks a milestone in understanding our place in the galaxy. It shows that planets form even around the smallest of stars, that the universe is not composed of suns alone, but of worlds. Perhaps countless worlds, each with its own story, its own quiet landscapes, its own relationship with the light that warms it. You drift with this thought as the spacecraft continues its gentle sweep around Proxima's orbit, collecting data that will one day be sent back across the stars. The journey home for these messages will take years, traveling at the speed of light. Long after the spacecraft has left Proxima behind, long after it has drifted back into interstellar darkness, its signals will still be crossing the gulf. When they finally reach Earth, they will be carrying the first direct information ever obtained from a planet orbiting the closest star to the Sun. Scientists, perhaps working in quiet labs somewhere far in the future, will examine the data closely, looking for patterns hidden in the noise. And in those patterns, the story of Proxima b will begin to take shape in numbers. It is a humbling thought that discovery often unfolds long after the moment itself has passed. The spacecraft witnesses this world now in the soft red light of a star 40 trillion kilometers from home. But the understanding, the interpretation, the meaning, it all waits patiently for its arrival on Earth. Interstellar exploration stretches not only distance, but time. It reminds humanity that discovery is rarely immediate. It is a long thread woven through generations, each one adding its own quiet contribution. As the spacecraft drifts farther through the Proxima system, the planet's orbit falls behind. Proxima b becomes a soft point of memory, an object it once passed near, a shadow that left a subtle mark in its instruments. ahead lies more of Proxima Centauri's quiet domain. Regions where dust gathers in thin strands, where magnetic fields twist softly, where particles drift in patterns, shaped by the cool, steady pull of the red dwarf. The spacecraft glides through these regions without mission or urgency. Yet its motion carries meaning, for it moves through a place no human eye has ever seen, no human mind has ever fully imagined. Even the light here feels different, older, softer, more deliberate. It reaches outward with less energy than the sun's, but with greater patience. Proxima Centauri burns slowly, carefully, conserving its fuel. While the sun may one day expand and fade, Proxima will continue shining long after. It will still be here, glowing in the darkness, long after the spacecraft's journey has become a story of the distant past. There is something comforting in this endurance, something steady and eternal in the quiet presence of a star built for longevity. You may imagine the spacecraft glancing back toward the distant twin suns of Alpha Centauri A and B. They gleam faintly on the horizon of the Proxima system, reminders of the warmth and brightness the spacecraft encountered earlier. Now, drifting in the cool red light of a star, a fraction of their size, the contrast becomes striking. 3 stars, bound by gravity across unimaginable distances, each with its own identity, its own color, its own life cycle. The spacecraft has seen them not from the ground, but from within their domain, a perspective no human has ever experienced. It is a witness to a stellar family, a small moving point bridging the space between siblings in an ancient dance. Here, at the heart of this distant system, the idea of arrival becomes something deeper than reaching a destination. It becomes a recognition that humanity, small and fragile though it is, has extended its understanding outward, not through conquest or presence, but through observation, through curiosity, through the gentle act of listening to what the universe has always been whispering. As the spacecraft continues its slow drift past Proxima B's orbit, one final thought settles into the quiet. This world, orbiting a small red sun, has existed in silence for billions of years. It has seen flares, storms, shifts in its star's brightness. It has turned through ages without witness, without interruption. And now, for the first time, something from a distant system has passed through its sky. The moment is quiet, but profound. The spacecraft does not linger. It moves onward, carried by momentum and the gentle curvature of gravity. But the significance remains. For in this brief encounter, this slow pass through a foreign orbit, humanity has touched a new chapter in its understanding of the cosmos. Proxima B grows smaller behind the spacecraft, its orbit fading into the red glow of its star. The journey continues, not toward a specific destination, but deeper into the meaning of exploration itself. In the vast silence of space, a single world around a small red sun becomes a reminder of how much remains unseen. How many stories await in the quiet corners of the galaxy? And you, drifting with the spacecraft in thought, feel the calm truth of this moment. The journey is not about arrival. It is about widening the circle of what is known, one gentle step at a time across the stars. Leaving the red star behind, there is a moment, subtle but unmistakable, when the spacecraft begins to drift beyond the influence of Proxima Centauri's closest embrace. The red dwarf remains bright behind it, glowing like a quiet ember suspended in the darkness. But the spacecraft's path now carries it outward, away from the orbit of Proxima b and into the broader, more open region where the star's light fades into a soft, deep twilight. The journey is not one of sharp transitions or sudden changes. It unfolds slowly, as gently as the dimming of dusk across a calm horizon. In this transition, the silence deepens, and the meaning of the voyage shifts once more. For a long time, the spacecraft has been surrounded by Proxima's quiet glow, moving through a region shaped by the cool red star's winds, flares, and magnetic fields. But as it glides away, each of those forces begins to soften. The density of charged particles falls. The fluctuations in radiation smooth into steadier patterns. Even the color of the light changes. The soft red that once filled its sensors gradually thins until it becomes only a faint memory of warmth. The spacecraft is returning to the deeper solitude of the system's outer reaches. A space not entirely dark, but illuminated by multiple suns at once, each shining with its own character. If you imagine drifting alongside the spacecraft at this moment, you might sense the vast emptiness opening before it. Proxima Centauri, though still visible, begins to resemble a distant lantern, comforting but small. Its glow appears warmer in contrast to the dark expanse ahead, its flares dimmed by distance, its round silhouette shrinking into the fabric of the sky. Behind it lies Proxima b, now only a phantom presence, a tiny world orbiting faithfully in its short 11-day cycle. Though the spacecraft carries no emotion, its trajectory carries a sense of departure, leaving behind a quiet world that has spun alone for billions of years. Ahead, the twin suns of Alpha Centauri A and B begin to brighten again, like distant beacons calling the traveler back toward the center of the system. Their combined glow is faint from afar, but unmistakable. Two lights joined in a long gravitational dance, often indistinguishable from a single star when viewed from Earth, yet now clearly separate, each carrying its own warmth and color. Their light reflects faintly off drifting dust grains, creating a delicate shimmer along the spacecraft's path, as though the space between stars were painted with starlight too subtle to see from any world. Between Proxima and the twin suns lies a vast region where the gravitational influences of all three stars blend into a complex, ancient balance. This region is quiet, but not empty. Thin threads of dust drift like pale smoke. Stray particles of gas move through magnetic fields shaped by three different stellar winds. It is here, in this gravitational crossroads, that the spacecraft travels now, slowly, steadily, without interruption. As the spacecraft enters this middle region, the background of the sky changes once more. The constellations bend slightly from this new vantage point, revealing the subtle truth that every place in the galaxy has its own version of the night sky. The stars you know from Earth still shine here, but their patterns shift. The Southern Cross stretches and softens. Centaurus bends at a different angle. Even the distant arc of the Milky Way appears slightly displaced, as if the galaxy itself has turned ever so gently since the spacecraft left home. These changes are delicate, almost imperceptible moment by moment, but the spacecraft sees them from a perspective that no human eye has ever known. Its journey has already carried it to a place where the familiar constellations feel like memories from another time, another sky, another world. And yet, even in this unfamiliar expanse, there is something deeply comforting about the presence of stars. They shine with the same calm persistence here as they do from Earth. Their light unchanged by distance, their glow a bridge across time, As Proxima Centauri recedes behind the spacecraft, the red dwarf becomes a marker of the journey already completed, a reminder of the small, quiet world hidden in its dim embrace. A world that may hold stories yet to be discovered. The spacecraft's sensors continue to record data, gathering information about the changing environment as it drifts farther from the star's influence. The waves of radiation soften. The magnetic fields fade. The winds become thinner, more diffuse, blending into the interstellar medium that spans the space between all stars. Here, in this transitional zone, the spacecraft feels the competing influences of three suns. The gravitational pull of Proxima grows weaker with each passing day, while the subtle tug from Alpha Centauri A and B grows stronger. Their light, though still distant, carries a warmth that contrasts softly with the cool red glow now fading behind. In the quiet of this region, the spacecraft becomes a bridge between the three stars, drifting along a path shaped not by any single sun, but by the quiet cooperation of all of them. You might imagine the spacecraft turning its instruments back toward Proxima one last time. The star still shines with a soft, ruby-colored light, small against the darkness. Proxima B remains hidden, too small and too far to reflect enough light to be seen directly. But its presence lingers, a quiet world that has been seen not with eyes, but with understanding. For the spacecraft, leaving Proxima means leaving behind the first truly alien world ever visited, even if only from a distance. It is a milestone not marked by sound or sight, but by the simple motion of crossing from one star's domain into the shared space between three. Ahead, Alpha Centauri A and B continue to brighten. Their light grows more defined, their colors more distinguishable, gold and amber, intertwined but separate. Their orbit, once invisible from afar, becomes clearer, revealing the shape of their gravitational bond. Though still distant, the stars feel closer now, guiding the spacecraft into the heart of the system with their warm, intertwined glow. As the spacecraft continues its journey, the darkness around it settles into a calm that feels different from the interstellar void. This darkness is shaped by stars, influenced by their presence, illuminated from afar by suns that share a relationship older than any world in the system. Gravity here is gentle but complex, shaped by the slow, patient orbits of the twin suns and the small, distant path of Proxima. In this moment, drifting between suns, the spacecraft embodies the quiet truth of exploration. That every journey leads not just to places, but to understandings, to deeper reflections about the nature of stars, of worlds, of time, and of humanity's desire to reach beyond its cradle. As Chunk 11 closes, the spacecraft continues its silent path away from the red glow of Proxima and toward the brighter realm of Alpha Centauri A and B. The journey is not over. It is changing, shifting from discovery to reflection, from the mystery of a distant world to the broader significance of standing between suns. And you, drifting beside it in thought, feel the calm beauty of this moment. A small machine moves through the quiet space between three stars, carrying with it the story of how far curiosity can travel across the cosmos. Into the heart of a three-star harmony. As the spacecraft leaves the dim glow of Proxima Centauri behind, the two main stars of the Alpha Centauri system begin to dominate the sky once more. Their combined light grows brighter with every passing day, though the distance between them remains immense. The golden radiance of Alpha Centauri A and the softer amber glow of Alpha Centauri B merge into a luminous pair, rising like twin lanterns suspended in the vastness. For the first time since its approach, the spacecraft feels the full complexity of navigating a region shaped by two suns instead of one. A gravitational ballet performed across billions of years and now witnessed by a traveler from another world. The journey inward is slow and unhurried. The pull of Proxima fades gently, and the gravitational influence of A and B grows gradually, as if the spacecraft is being welcomed back toward the warmer heart of the system. Here, in the region between the three stars, gravity is a delicate interplay, a network of invisible threads pulling and guiding, intersecting and bending. No single point belongs to any one star entirely. Every movement is influenced by all three, a quiet collaboration sculpted by the mathematics of orbits older than recorded history. As you drift with the spacecraft, you can sense these changes not through force or motion, but through the patterns of light and space unfolding ahead. Alpha Centauri. A begins to take on the familiar qualities of a true sun. Warm, bright, steady. Its surface boils with convection, releasing light that seems to carry a quiet, golden certainty. Beside it, Alpha Centauri B glows more softly, like a companion fire whose warmth complements rather than competes. Their shared orbit is slow, deliberate, and graceful, played out over a span of more than 70 years. From the spacecraft's perspective, the two stars no longer appear as a distant pair. They have become celestial bodies with individuality, two characters in a cosmic dialogue. The distance between them is vast, yet they remain bound by a gravitational tie so perfect in balance that their dance has endured since long before Earth's continents first formed. Their orbits, shaped by time and physics, create a gentle rhythm across the space around them, a slow heartbeat that the spacecraft can sense as it drifts closer. It is here, in this region between the stars, that dust and gas create intricate pattern. Streams of microscopic particles curve gently through space, guided by the combined pull of A and B. Some drift into stable orbits, forming faint, shimmering belts like soft halos suspended in darkness. Others drift freely, carried along paths shaped by the shifting gravity of the twin suns. For the spacecraft, these particles are not hazards, they are guides, markers of the invisible forces at work around it. Their presence hints at the history of the system, the collisions, the formations, the remnants of worlds that might once have taken shape or may yet emerge in the distant future. As the spacecraft moves deeper into this luminous region, the interplay of light grows richer. Shadows shift with greater complexity, cast by two sources instead of one. Dust grains reflect gold on one side and amber on the other. If a world existed here, its skies would shimmer with layered colors, its horizon touched by two distinct hues. The light of A would be dominant, strong and steady. The light of B softer, more diffuse. Together, they would paint a world with patterns of illumination unknown on Earth. A sky where day could carry two suns at once, each casting its own path of brilliance. Though no confirmed planets circle the twin suns, the spacecraft's instruments search carefully. It detects subtle variations in motion, faint anomalies in the flow of gas, small shifts in background radiation. These traces might indicate dust belts, asteroid groups, or regions where planets once formed before being drawn inward or pushed outward by the star's gravitational interplay. Every measurement adds to a mosaic, a deeper understanding of how binary systems shape worlds, life, and time itself. The spacecraft drifts through this region with a calm inevitability. Its momentum carries it toward the center of the Alpha Centauri AB orbit, a space where the gravitational forces of both stars balance into a stable harmony. Here, the pull of each star is equal, creating a quiet point in the system's architecture, a location that exists only because two suns share a bond. This is not a resting place, not truly still, but it is a place of gentle equilibrium. For a moment in its long journey, the spacecraft passes through this invisible balance point, becoming, if only briefly, a witness to a cosmic serenity unreachable in a single star system. From this vantage point, the twin suns almost appear as equals, two radiant spheres suspended in perfect opposition. Their colors blend across space in ripples of gold and amber, illuminating the faint dust around the spacecraft like a veil of floating light. The darkness between them is not empty. It is alive with the glow of two stars meeting gently at the center of their shared universe. You might imagine approaching this point as a kind of cosmic meditation. The light around you is soft and layered, the shadows complex, the vastness immense yet strangely intimate. The stars do not rush or flicker, they endure. And in their endurance, there is a quiet message about the nature of the universe. That time can be slow, that relationships between stars can last billions of years, that beauty can exist not in motion alone, but in balance. Beyond this harmonized region, the gravitational pull of Alpha Centauri A begins to dominate once more. It is the larger of the two, slightly brighter, slightly more massive, its influence stretching farther across the system. The spacecraft feels this shift not as a sudden change, but as a gentle leaning, a subtle curve in its path. Light grows warmer, space grows brighter. The golden star becomes the new center of orientation, pulling the traveler closer. Alpha Centauri. A shines with a familiarity that is almost unsettling. Its spectrum is nearly identical to that of the sun. Its surface churns with convection cells, bright and hot, forming the same patterns of light and shadow observed in Earth's own star. For a moment, the spacecraft seems to drift towards something that feels like home. Not in distance, but in the simple truth that stars like this one have given life to worlds across the galaxy. It is a reminder that the sun is not unique, that its warmth is not an isolated miracle, that the universe holds countless opportunities for life to take hold. As Chunk 12 draws to a close, the spacecraft coasts deeper into the gravitational heart of the Alpha Centauri system. Proxima now glows faintly behind it. Alpha Centauri A and B shine brightly ahead. The dust around the traveler shifts into new patterns, following the invisible architecture of two stars locked in an ancient embrace. And you, drifting with it, feel the quiet truth of this moment, that even in a system far from home, even in a sky shaped by three suns, there is harmony, subtle, patient, enduring. The journey continues, guiding you toward the bright golden star ahead and the deeper meaning hidden within its quiet light. Alpha Centauri A, the familiar light of a distant sun. As the spacecraft drifts deeper into the Alpha Centauri system, the golden light of Alpha Centauri A grows brighter with a steady, reassuring warmth. For the first time since leaving the solar system, the spacecraft approaches a star so strikingly familiar that its glow seems almost like a memory rather than a distant radiance. Its spectrum is nearly identical to the sun's. Its warmth, though faint from afar, carries the same quiet promise. Its surface, roiling with convection and shaped by magnetic fields, looks like a reflection of the star that once illuminated Earth. And yet, this is not the Sun. This is a distant sibling, similar but ancient in its own way, shaped by a life lived far from the cradle of humanity. Slowly, gently. Alpha Centauri. A fills the spacecraft's forward view. Its yellow-white radiance spills outward across the darkness, revealing the subtle texture of interstellar dust now drifting behind in soft trails. As its light grows stronger, the spacecraft detects the faint warmth from its stellar photons. Not enough to heat its cold metal frame, but enough to register as an unmistakable presence, a star shining with the energy of a familiar lineage. Unlike the red glow of Proxima Centauri or the softer amber hue of Alpha Centauri b, this star burns with a brilliance that speaks of life and possibility. Stars like Alpha Centauri a are the architects of worlds. Their energy warms planets, stirs atmospheres, drives winds and currents, and sparkles across the surfaces of oceans, if any exist within their embrace. The spacecraft knows none of this directly, but its instruments begin to translate the star's secrets with quiet precision, painting a portrait of a world that might have been a second home for life under the right conditions. Alpha Centauri A is slightly larger and brighter than the Sun, its mass just a bit greater, its temperature only a few degrees hotter. Yet these differences, while subtle, shape the rhythm of the star's light. Its convection currents rise and fall with a pattern almost identical to the Sun's, but with a shimmer that gives Alpha Centauri A its unique personality. Sunspots drift across its surface, darker patches formed by magnetic activity, coming and going in cycles that span years. The spacecraft watches these patterns from afar, its sensors tracing the subtle fluctuations that ripple from the star's surface into the surrounding void. As the spacecraft closes its distance, the sky around Alpha Centauri A brightens into a soft halo. Dust grains drifting near its path reflect golden light, creating faint specks that glitter like distant embers. In this glow, the spacecraft becomes a silhouette, a small dark shape crossing the light of a sun that no human being has ever seen from this vantage point. If you imagine drifting with the spacecraft, the star appears immense, filling the view with a comforting radiance that evokes the memory of Earth's sky. In this light, the difference between home and the distant cosmos feels smaller, softened by the familiarity of a star whose warmth mirrors that of the Sun. It is almost as if, after crossing the cold darkness between stars, the spacecraft has arrived at a place that feels gently welcoming. Not because it is home, but because it reminds you of home. Alpha Centauri. A's gravity shapes the region around it with quiet authority. Even at great distances, its pull is unmistakable. If planets circle this star, hidden, unconfirmed, but possible, they would follow long, graceful orbits shaped by billions of years of gentle stellar influence. And while no such planets have been definitively seen, the spacecraft begins to search for hints. Subtle dips in brightness, tiny wobbles in the star's motion, faint distortions in the surrounding dust. Every star carries stories in its light, stories of past flares, of magnetic storms, of cycles that stretch across decades. Alpha Centauri A is no exception. The spacecraft detects occasional bursts of energetic particles, small compared to those produced by younger, more volatile stars, but characteristic of a mature, stable sun. These bursts wash gently across space, their intensity reduced by distance, their patterns revealing the life and activity of a star that has burned quietly for billions of years. As the spacecraft continues to approach, it becomes clear that Alpha Centauri A is more than a destination. It is a witness to time, a luminous being that has endured for nearly as long as the Sun. It has watched the galaxy rotate around its center. It has seen nearby stars drift in and out of view. It has shared its existence with Alpha Centauri B and Proxima Centauri since their earliest days, bound in a gravitational relationship that stretches back to the dawn of stellar formation in this region of the galaxy. You might imagine what life would be like if a world orbited here in the habitable zone. If oceans sparkled beneath this golden light, if skies warmed under its steady glow, if winds moved across landscapes shaped by a sun, not unlike the one that nurtured life on Earth. Perhaps such a world once existed here, formed in the early lifetime of the star, only to be scattered by the gravitational influence of the binary system. Perhaps such worlds will form again millions of years from now. Or perhaps they exist still, too distant or small for any telescope to confirm. The spacecraft is not here to answer these questions. Yet its presence, its quiet drift into the light of Alpha Centauri A, carries the hope that one day humanity will understand these distant worlds more fully. It carries the promise that exploration does not end with Earth, nor with the solar system, but extends outward to all the stars that share this galaxy's spiraled expanse. Even now, as the spacecraft absorbs and analyzes the star's light, it becomes a messenger for the future. The photons it collects, the data it gathers, the patterns it records, all will one day travel back across the interstellar distance, returning to the Sun long after the spacecraft has passed beyond the heart of this foreign system. When that information reaches human scientists, perhaps decades later, it will tell the story of a star seen up close by a traveler from another world, an achievement that once seemed beyond imagination. And so, as Chunk 13 comes to a gentle close, the spacecraft continues its quiet journey toward Alpha Centauri A. Its sensors open, its instruments humming softly in the golden glow of a star that mirrors the Sun. It drifts into a place where familiarity meets wonder, where the light of another sun illuminates the darkness, and where the idea of home grows both smaller and larger. Smaller in the vastness of space, larger in the shared truth that stars like this exist everywhere. The journey continues, deeper into the understanding of this distant system, guided by the warm and steady light of Alpha Centauri A. Alpha Centauri, the silent companion of a distant sun. As the spacecraft settles deeper into the luminous realm of Alpha Centauri A, another light begins to assert itself on the horizon, a softer radiance, warm but subdued, glowing like the ember of a fire that burns lower and gentler than its brilliant companion. This is Alpha Centauri B, the second star of the pair, circling its sibling in an orbit so steady and graceful that it has remained unchanged for billions of years. From afar, the two stars appear as one blended point of golden light. But here, within the heart of their shared system, the distinction becomes clear. Alpha Centauri A shines with the confident brightness of a powerful sun. Alpha Centauri B glows with a quieter, amber warmth, subtle and serene. If you drift with the spacecraft in your imagination, Alpha Centauri B appears as a perfect complement to its companion, smaller, dimmer, cooler, yet deeply luminous in its own way. Its light is softer on the eyes, casting long, gentle shadows across the dust drifting in the region, where Alpha Centauri, Irradiates an assertive brilliance, B offers a quieter glow, its surface shimmering with patterns of convection that rise and fall in slower, calmer cycles. Together, the two stars illuminate the darkness with a harmony found only in binary systems. Two voices speaking in complementary tones, shaping the region they share. The spacecraft, drifting between them, becomes a witness to their relationship. Alpha Centauri b follows its long, elliptical orbit with unwavering precision, drawn toward and pulled away from its companion in a cycle lasting more than 70 years. Though it moves slowly on the human scale, the spacecraft feels the shift in their gravitational balance as it drifts closer to the amber star. Space here is not dominated by a single gravitational well. It is shaped by two, forming a complex tapestry of forces. Dust paths curve in loops and spirals. Small objects drift along routes that would be impossible in the solar system. The spacecraft senses all of this through the gentle push and pull of gravitational tides, each one whispering the presence of two suns at once. Alpha Centauri b is slightly smaller than the Sun. Its mass reduced, its temperature lower, its light tinted with a deeper hue. And yet, this subtle difference creates an entire world of contrast. The star burns through its fuel more slowly, extending its lifespan, giving it a quiet endurance that matches its warm glow. If planets orbited this star, and it is possible they once did, they would have experienced a softer climate, a gentler daylight, a sky illuminated by both suns on certain horizons. The light of A would have added a golden shimmer to B's amber glow, blending into a palette no world in our solar system has ever known. As the spacecraft approaches, Alpha Centauri b grows brighter, its soft radiance touching the hull with faint golden warmth. Its photosphere, its visible surface, churns with convection cells similar to those on the Sun, but smaller, cooler, slower. These cells rise like hot air from boiling water, creating patches of brightness across the star's glowing face. Dark spots drift across it as well, regions where magnetic activity suppresses convection, forming sunspots that come and go in long cycles. The spacecraft's instruments detect these variations with quiet precision, measuring the star's subtle pulses like a doctor listening to the heartbeat of a celestial being. Unlike its companion, Alpha Centauri b has a reputation for stability. Its magnetic field is calm, its stellar winds moderate, its flares rare compared to more active stars. Where Proxima Centauri rages with sudden bursts of energy, Alpha Centauri b breathes with serene consistency. This stability is part of what makes it such an intriguing star for astronomers. A star that might nurture planets in long-term climates suitable for life, if only such worlds exist. As the spacecraft drifts closer, the environment begins to glow with the united light of both stars. Shadows lengthen and soften, illuminated from two directions. Dust grains sparkle as they catch the amber glow of B on one side and the golden shine of A on the other. Even the darkness takes on a texture, as if filled with faint layers of color too subtle to see from Earth. The spacecraft passes through this luminous region like a small figure moving across a canvas painted by two suns, one strong and bright, the other warm and gentle. Here, the gravitational influence of Alpha Centauri b becomes more pronounced. Its pull shapes the spacecraft's path, adding a delicate curvature to its motion. The star's light presses softly against the hull. Its radiance overlaps with that of Alpha Centauri A in soft waves, creating a landscape of illumination that shifts with every small movement of the spacecraft. Imagine a world orbiting here, a world where the day begins with an amber sunrise from Alpha Centauri b and ends with a golden glow from Alpha Centauri A. Imagine a horizon where two suns hang at different heights, each casting its own light across oceans or plains. Nights might never be fully dark if the stars align. Seasons might carry the rhythm of two stellar cycles at once. Shadows might dance in overlapping patterns no Earth-born eye has ever seen. The Alpha Centauri system holds such beauty and potential, even if no such world exists today. As the spacecraft approaches the inner regions of Alpha Centauri B's gravitational domain, its instruments detect the star's stellar wind, a gentle stream of charged particles drifting outward across space. These particles are fewer and cooler than those from Alpha Centauri A, but they carry the same signature of life, the same evidence of a star's internal fire. The spacecraft measures their density, their speed, their composition, each one a clue to the star's behavior. And then, slowly, the spacecraft passes beneath the full warmth of Alpha Centauri B. Its light envelops the small traveler in a soft, amber glow. The star fills a portion of the sky with gentle radiance, warming the darkness with a hue reminiscent of deep sunsets on Earth. It is a light that speaks not of power, but of calm endurance. A glow that has shone for billions of years and will continue for billions more. From this vantage point, the spacecraft sees Alpha Centauri A and B not as separate entities but as partners. Two suns sharing a journey through the galaxy, bound by gravity, illuminating the void with their combined brilliance. The spacecraft, drifting between them, becomes a silent witness to their timeless relationship. As Chunk 14 draws to a close, the spacecraft begins to move beyond the central glow of Alpha Centauri B. The star's warmth fades slowly, blending again with the golden light of its companion. The region ahead is shaped by both suns, a shared expanse illuminated by two sources of radiance, bound by a harmony of gravitational tides. And you, drifting with it in thought, feel the beauty of a journey carried through a system of suns. A place where light comes in pairs, where shadows hold color, where time unfolds across a dance billions of years old. Beyond the light of three suns, there comes a moment in every long journey when even the brightest stars begin to fade and the horizon opens not toward a destination, but toward continuation. As the spacecraft drifts gently beyond the combined glow of Alpha Centauri A and B, leaving their warm golden and amber radiance behind, the light softens into a delicate haze. Their brilliance, once powerful and commanding, now melts slowly into the distance. The two stars shrink back into the quiet, returning to the shape they had before the spacecraft ever arrived. 2 points of light dancing around one another, ancient and enduring, unaware of the small traveler that passed through their glowing domains. Proxima Centauri 2 lingers far behind, no more than a faint red pinprick against the vast canvas of night. The three stars that once surrounded the spacecraft now recede into memory, each one a chapter in the long passage across the interstellar sea. Their gravitational voices grow quieter. Their winds soften. Their light dims, and gradually, the environment shifts once again from the complex balance of a triple star system into the open, unbounded stillness of deep space. If you imagine yourself drifting with the spacecraft, this is a moment that feels both solemn and serene. A moment where the infinity ahead is no longer defined by arrival or exploration, but by the simple continuation of motion. The spacecraft does not turn back. It does not anchor itself to any star. It moves onward, carried only by the momentum given to it long ago. A messenger gliding through time with no requirement to hurry or return. In the cooling glow of Alpha Centauri fading behind it, the spacecraft becomes once more a traveler of the void, slipping into the dark sea that stretches between the stars. As it leaves, the region behind it holds echoes of what has been witnessed. The gentle red glow of Proxima, the warm gold of Alpha Centauri A, the quiet amber of Alpha Centauri B. Their lights overlap in memory, like the fading colors of a sunset long after the sky has grown dark. Each star has its own story, its own presence, its own influence on the surrounding space. Together, they form a celestial family, one that the spacecraft has passed through with a patient calm, gathering what knowledge it can before continuing deeper into the galaxy. In this quiet transition, the stars begin to realign into their distant positions. From the spacecraft's new vantage point, the familiar patterns of Earth's constellations are distorted, stretched into shapes no human eye has ever seen. The Southern Cross, once a stable guide for navigators on Earth, now leans at a different angle. Centaurus bends and curves in new ways. Even the broad band of the Milky Way shifts slightly across the sky. The spacecraft drifts through a universe where the night looks different, where every direction carries a reminder of how far it has traveled. Yet, despite the vastness, there is comfort in this darkness. Interstellar space, though nearly empty, is not lonely. It carries the soft afterglow of stars long gone and the faint promise of stars not yet born. It holds the memory of ancient galaxies and the potential for distant futures. And into this quiet, unbroken expanse, the spacecraft carries a new story, one shaped by its passage through the closest neighbors to the Sun. As it travels, the spacecraft's instruments continue to listen. They measure the subtle temperature of the cosmic background. They feel the slow drip of interstellar particles crossing their path. They sense the gentle hum of radiation that has traveled across millions of years. Even in silence, the universe speaks through these faint signals, signatures of forces too large to witness directly, but too constant to ever disappear. Far behind, the three stars of Alpha Centauri continue their timeless orbits. Proxima circles distantly. A and B curve around each other with elegant patience. Their dance will continue for billions of years, long after the spacecraft has vanished into the deeper reaches of the galaxy. Long after humanity has changed or evolved or moved on to other worlds. And yet, the fact that a machine from Earth once drifted through their light becomes part of their story now. A small, quiet footnote in the eternal unfolding of their existence. If you were to look back from the spacecraft's vantage point, the three stars would appear as a tiny cluster of light. The Sun, far behind them, would be invisible to any eye, lost beyond trillions of kilometers of darkness. And ahead, only the unending silence of the interstellar medium, a silence filled not with emptiness, but with potential. Beyond the reach of Alpha Centauri lies the next stretch of the galaxy, the next collection of stars, the next set of worlds waiting quietly in the dark. Humanity may never follow this spacecraft in person. Or perhaps one day, distant descendants will look back at this early interstellar traveler, the way early explorers on Earth once looked at their first ships, symbols of beginnings. For now, the spacecraft remains a solitary messenger, carrying with it the whisper of a world that looked up at the night sky and wondered what lay beyond. As the glow of Alpha Centauri fades completely, the darkness returns to its full depth. Yet something is different now. The stars no longer feel distant and unreachable. They feel connected, part of a larger whole that humanity has begun to touch. The spacecraft's journey has not changed the stars, but it has changed the meaning of distance. It has changed the scale of what is possible. Ahead lies a future written not in maps or boundaries, but in curiosity. The spacecraft drifts onward, patient and unhurried, its trajectory carrying it farther into the cosmic ocean. And behind it, in the memory of its voyage, lies the first chapter of interstellar exploration. A journey that began in the warm light of the sun and led to the gentle glow of 3 distant stars. As this final chapter settles softly in your mind, you realize something quiet and profound. Interstellar travel is not defined by how fast we move or how far we go. It is defined by the simple act of reaching, of extending curiosity beyond the horizon, of touching the unknown with patience, humility, and wonder. And so the spacecraft continues, a small shape drifting through a vast, calm darkness, carrying the story of Earth, of humanity, and of the quiet hope that the universe is not a place to be crossed, but a place to be understood, one gentle step at a time.